As designers and specifiers, you are continually challenged to create structures that are not only safe, durable, and cost-effective, but also environmentally sustainable. In our quest to achieve this balance, one of the most powerful tools at our disposal is the Environmental Product Declaration, or EPD. Today we will focus specifically on EPDs for ready-mixed concrete, a fundamental material in our industry. The environmental impact of concrete, particularly its contribution to greenhouse gas emissions, has come under increased scrutiny. As the demand for sustainable construction grows, understanding the environmental implications of the materials we specify becomes crucial. This is where EPDs come into play. Our learning objectives for today's presentation include what EPDs are, understanding the basics of environmental product declarations, the importance of EPDs, why they matter in the context of ready-mixed concrete, components of an EPD, breaking down the key elements and what information they provide, GWP targets, setting and understanding global warming potential targets for your projects, practical applications, how to effectively use EPDs in specifying ready-mixed concrete, and industry standards and benchmarks, aligning your practices with current standards and benchmarks. Why all of this matters. Incorporating EPDs into our engineering practice not only helps us to meet regulatory and certification requirements, but also positions us as leaders in sustainable construction. Our choices today will have a lasting impact on the environment and future generations. So let's dive into the world of EPDs and explore how we can use this powerful tool to build a more sustainable future with ready-mixed concrete. An environmental product declaration is an independently verified document defined by the International Organization of Standardization, Section 14025, as a declaration that quantifies environmental information on the life cycle of a product to enable comparisons between products fulfilling the same function. Industry and government entities are driving change. Today, LEED version 4, Architecture 2030 Challenge for Products, Portland Cement Association Net Zero 2050, and the International Green Construction Code are just some of the industry and regulatory bodies requesting that building product manufacturers submit EPDs to demonstrate the environmental performance of their products. But why EPDs? EPDs offer three major purposes: transparency, comparability, and they define the sustainability goals. EPDs offer transparent information about the environmental impact of products. They offer detailed environmental data, helping engineers, architects, and builders make more informed decisions about the material they use. EPDs facilitate clear communication of environmental impacts to stakeholders, including clients, regulatory bodies, and the public. They allow for comparison between products with similar functions. EPDs provide a standardized method to quantify the environmental impacts of concrete through life cycle assessments. This helps in identifying the most significant environmental aspects and areas for improvement. EPDs allow for the comparison of different concrete mixes and products based on their environmental performance, enabling better decision-making and material selection. And EPDs help in achieving sustainability goals and certifications such as LEED. Concrete has been targeted for EPDs for several reasons, primarily due to its widespread use and significant environmental impact. Concrete is the most widely used construction material globally. Its applications range from residential buildings to infrastructure projects like roads, bridges, and dams. The sheer volume of concrete produced annually make it a significant focus area for reducing environmental impacts. Concrete has a high environmental impact that can be traced to the production of cement. A key ingredient in concrete, it is responsible for a substantial portion of global CO2 emissions. Cement production alone accounts for approximately 7 to 8% of global CO2 emissions. Concrete production requires large quantities of raw materials, including cement, aggregates, water, and energy, leading to resource depletion and environmental degradation. As always, there is a potential for improvement. There are opportunities to reduce the environmental impact of concrete by using alternative materials, such as supplementary cementitious materials like fly ash, slag, and silica fume. Also, advances in production techniques, carbon capture and storage, and the use of recycled materials can significantly lower the environmental footprint of concrete. Another option is Portland limestone cement, which allows between 5 and 15% of limestone in the clinker for cement production. There continue to be regulatory and market pressures. Increasing regulatory requirements and voluntary sustainability standards, such as leadership in energy and environmental design, and building research establishment and environmental assessment methods, encourage or mandate the use of materials with lower environmental impacts. There is also a growing awareness and demand for sustainable construction practices from clients, investors, and the public, which drive the need for transparent environmental information. EPDs provide a standardized method to quantify the environmental impacts of concrete through life cycle assessments. This helps in identifying the most significant environmental aspects and areas for improvement. EPDs allow for the comparison of different concrete mixes and products based on their environmental performance, enabling better decision-making in material selection. EPDs offer detailed environmental data, helping engineers, architects, and builders make more informed decisions about the material they use. EPDs facilitate clear communication of environmental impacts to the stakeholders, including clients, regulatory bodies, and the public. EPDs help set benchmarks for the industry, encouraging manufacturers to adopt best practices and innovate to reduce their environmental footprint. Companies that produce and use concrete with favorable EPDs can differentiate themselves in the market as leaders in sustainability. Targeting concrete for EPDs is a strategic move to address one of the largest contributors to the environmental impacts in the construction sector. By providing transparent, standardized environmental data, EPDs drive improvements in sustainability, inform better decision-making, and support regulatory compliance and market demands for greener construction practices. The content of an EPD includes the following: product information, life cycle assessment results, or better known as LCA, environmental impact categories, and data quality. Product information is the basic description, intended use, and specifications of the product. Life cycle assessment results provide us with the environmental impact metrics over the product's life cycle, typically including stages from raw material extraction to end-of-life disposal. EPDs for concrete are typically LCAs that look at cradle to gate. This includes material extraction and processing, transportation of materials, and the production of concrete. Environmental impact categories are common categories which include global warming potential, ozone depletion, acidification, eutrophication, and photochemical smog. And data quality provides us the information on the quality and source of data used to construct the life cycle assessment. What do all those big phrases mean? Let's look at them one by one. The US EPA defines global warming potential as a measure of how much energy the emissions of 1 ton of gas will absorb over a given period of time, relative to the emissions of 1 ton of carbon dioxide. It is expressed in kilograms of carbon dioxide equivalent because carbon dioxide is not the only greenhouse gas. Ozone depletion potential is a measure of how much damage a chemical can cause to the ozone layer in comparison to a similar amount of trichlorofluoromethane. Acidification potential refers to the compounds that are precursors to acid rain. These include sulfur dioxide, nitrogen oxides, nitrogen monoxides, nitrogen dioxides, and other various substances. Acidification potential is usually characterized by SO2 equivalence. Eutrophication potential is the potential to cause over-fertilization of water and soil, which can result in an increased growth of biomass. Photochemical smog creation potential is the formation of reactive chemical compounds such as ozone by the action of sunlight on certain primary air pollutants. These reactive compounds may cause serious human health problems. Abiotic depletion potential for elements and/or fossils is a method for measuring the depletion of non-living resources or abiotic resources from the Earth. It's used as an indicator of environmental impact for both fossil and non-fossil resources. Abiotic depletion potential is calculated by dividing the ratio of a resource's annual production to its ultimate reserve by the same ratio for a common resource, usually antimony. The result is measured in kilograms of antimony equivalents. The product category rule is a copyrighted document that is part of the EPD cookbook and contains the recipe to create a high-quality EPD for a product category. Product category rules may be developed by a group of stakeholders that could include trade association, manufacturers, or other institutions that demonstrate the competency to create the document. Product category rules are meant to be objective, defining documents that serve as the guidelines for life cycle assessments, which in turn inform environmental product declarations. They help to promote fairness by ensuring that all the products of the same type are measured with the same yardstick. If a life cycle assessment is going to be used for an environmental product declaration, the corresponding product category rule has to follow ISO 14025, which defines and helps standardize product category rules. In theory, product category rules should be reproducible with all value judgments taken away. As previously stated, an EPD for ready-mix concrete typically has a life cycle assessment of cradle to gate, from raw material extraction to the factory gate before it's transported to the consumer. If we look at cradle to grave, we are looking at a process that encompasses raw material extraction through the product's use and disposal. Cradle to cradle includes reuse or recycling at the end of the product's life. The product category rules establishes the principles and specifies the procedures for developing the Type 3 Environmental Product Declaration Program and the Type 3 Environmental Declarations. It specifically establishes the use of ISO 14040 series of standards in the development of the Type 3 Environmental Declaration Program and the Type 3 Environmental Declarations. It also establishes principles for the use of environmental information in addition to those given in the ISO 14020-2000. The product category rules are specific rules for developing EPDs for a particular product category, ensuring consistency. Product category rules must be ISO 14025-2006 compliant. This establishes the principles and specifies the procedures for developing Type 3 environmental declarations. A Type 3 EPD is verified by a third party called the program operator and must meet the product category rule for the product. It must include a life cycle assessment for a cradle to gates minimum, but it may also be determined cradle to grave perspective. As we've stated, concrete environmental product declarations and life cycle assessments are valuable tools for assessing the environmental impacts of concrete products. However, they have several shortcomings. The quality of the data can vary significantly, and obtaining accurate representative data for all life cycle stages can be challenging. Some assessments may not cover all stages of the life cycle, such as end of life or transportation impacts, leading to an incomplete picture. Ready-mix concrete life cycle assessments typically cover cradle to gate, which only focuses on the environmental impacts from the extraction of raw materials, or cradle, up to the point where the products leave the manufacturing facility, or gate. It does not include the impacts associated with the product's transportation, use, maintenance, or disposal. Also keep in mind that not all environmental impact categories are always considered. Some EPDs may focus on a limited set of impacts, such as global warming potential, while ignoring others, such as biodiversity. There also may be trade-offs between impacts. You may realize an improvement in one impact category, which may lead to worsening in another, and these trade-offs are not always clearly communicated. EPDs and LCAs typically focus on environmental impacts and often exclude economic and social impacts, which are also important for sustainability assessments. These shortcomings suggest that while EPDs and LCAs are valuable tools for assessing the environmental impacts of concrete, they need to be used with an understanding of their limitations and in conjunction with other assessment methods to provide a more comprehensive sustainability evaluation. Type 3 environmental declarations are described in ISO 14025-2006 and are primarily intended for use in business-to-business communication, but their use in business-to-consumer communication under certain conditions is not precluded. ISO 21930-2017 covers sustainability in buildings and civil engineering works. It provides core rules for environmental product declarations of construction products and services. It complements ISO 14025 by providing specific requirements for the EPD of construction products and services. We've mentioned program operator previously, but what is an EPD program operator? The task of the program operator is to carry out the environmental declaration program. In simple terms, this means publishing and managing the EPDs. The National Ready Mix Concrete Association, or NRMCA, is the program operator for environmental product declarations for ready-mixed concrete. The NRMCA is a nonprofit organization that helps producers and suppliers meet requirements for LEED 4, the International Green Construction Code, and the Architecture 2030 Challenge for Products. The NRMCA's EPD program helps producers by connecting them with life cycle assessment practitioners who create the life cycle assessment reports and draft the environmental product declaration documents. The NRMCA also verifies the information in the EPDs to ensure it complies with ISO 21930 and the North American Product Category Rules for Concrete. The concrete PCR is currently managed by NSF International, and version 2.0 was released on February 22, 2019. The Carbon Leadership Forum originally developed the product category rules in 2012, and it has since undergone revisions and clarifications. Keep in mind, some factors to consider when buying ready-mix concrete include the amount of concrete needed for the project, the type of concrete required, the concrete's workability, its density and strength, its durability, affordability, and choosing a reputable supplier and/or hiring a local supplier to save money. The product category rules for concrete have very specific considerations. We look at ingredients, production methods, transportation, and performance requirements. Ingredients include the impact of the cement, aggregates, water, and admixtures on environmental performance. Production methods measure the variations and impacts based on production techniques and efficiencies. The effects of transporting raw materials and finished products must be considered, and also the performance requirements are balancing the environmental impact with structural and durability requirements. Understanding EPDs allows engineers to contribute to more sustainable construction practices by making informed choices about the materials and their environmental impacts. But just where do you start? Where do you begin? How do you know what a reasonable global warming potential target goal is? Should you choose a GWP for each concrete mix used on the project, or should you choose a project total GWP? Choosing a GWP target involves balancing environmental, economic, and performance characteristics. These goals should be realistic targets establishing both short-term and long-term GWP reduction targets. The short term might focus on easily achievable change, while the long-term targets can be more ambitious. Allow time for adaptation and technology advancements as new sustainable materials are being introduced. We need to develop a detailed plan for implementing the GWP reduction strategies by assigning responsibilities and setting timelines. Continuously monitor the GWP performance using the life cycle assessment tools and adjust strategies as needed based on the performance data. Review the material selection, choose the concrete mixes with lower environmental impacts while meeting performance criteria. Contributing to the green building certifications by using materials with EPDs and meet environmental regulations and standards. This map represents the U.S. national and 8 NRMCA regions for 9 benchmark ready mixed concrete products, which vary by compressive strength and cementitious material content. The benchmark concrete products also include 3 lightweight mix designs in each region. Each NRMCA region is represented in a separate section, and the results are presented so companies with third-party verified life cycle assessments and/or EPDs can benchmark their products against the regional benchmarks. For each region, a production summary is provided indicating the number and type of plants the benchmark is based on, and the average, minimum, and maximum production per plant. The regional report then presents the 6 normal weight bench ready mixed concrete products by compressive strengths. They include 2,500 psi, 3,000 psi, 4,000 psi, 5,000 psi, 6,000 psi, and 8,000 psi, as well as 3 lightweight compressive strengths including 3,000 psi lightweight, 4,000 psi lightweight, and 5,000 psi lightweight. The mixture proportions of each concrete product is also shown for reference purposes, and these vary by region. The report then shows the weighted average transportation mode and distance for high mass materials. While truck transportation is the dominant mode, a number of raw materials and intermediate product inputs arrive via more than one mode, such as barge or rail. In this slide, we see the life cycle analysis results for the 9 benchmark concrete products, and they're presented on a cubic yard basis. The purpose of the benchmark chart is to be used as a comparison tool and promote performance improvement. The chart serves as a reference to compare the GWP and other environmental impacts of a specific concrete mix against national averages. It helps producers identify areas where they can improve their mixes to reduce environmental impacts. To read the chart, we see the vertical axis represents the level of environmental impact, kilograms of CO2 equivalent for the global warming potential as an example, while the horizontal axis lists the different concrete mix designs or classes. By looking at the benchmark lines, we see the national average lines for each impact category against which specific mixes can be compared. The basic use of this chart is for comparison, goal setting, and reporting. Producers can plot their own EPD results on the chart to see how they compare to the national benchmarks. Areas can be identified where mix exceeds benchmarks and set goals for improvement. We can use the benchmarks to communicate environmental performance to clients and stakeholders. The benefits of using the chart include transparency, areas of improvement, and market differentiation. It provides a clear and standardized way to report and compare environmental impacts. It encourages continuous improvement by highlighting areas with the greatest potential for environmental benefit and helps producers demonstrate their commitment to sustainability and potentially gain competitive advantage. Pennsylvania is included in the Eastern region, and these charts show the data used to develop the benchmarks for this region. 65 ready-mix plants contributed to the development of the Eastern region benchmarks, with 63% being transit mix plants and 37% being central mix plants. The average production per plant was 59,453 cubic yards. The total production was 3,864,451 cubic yards. The minimum production per plant was 1,734 cubic yards, and the maximum production per plant was 307,863 cubic yards. Also shown are the mix designs per cubic yard for the 9 benchmark mixes. The transportation modes and distance chart help understand how different transportation modes such as rail, truck, or barge and distance affect the environmental impact of the concrete production. This chart provides a benchmark for typical transportation practices in the eastern region of the United States. The NRMCA Eastern Transportation Modes and Distance chart is a valuable tool for understanding and improving the transportation-related environmental impacts of concrete production and encourages stakeholders to use the chart data to optimize their transportation strategies and contribute to more sustainable concrete production. To explain the Eastern Gate-to-Gate Manufacturing Energy Use Chart for environmental product declarations, it involves breaking down its components, purpose, and usage. The chart helps understand the energy consumption involved in the concrete manufacturing process and provides a benchmark for typical energy use in concrete manufacturing in this eastern region of the United States. The components of the chart include energy sources, energy consumption data, and process stages. Energy sources include various types of energy used in manufacturing, such as electricity, natural gas, diesel, and other fuels. Energy consumption data shows the amount of energy consumed per unit of concrete produced, such as kilowatt hours per cubic yard. And the process stages may break down energy use by different stages of the manufacturing process, such as mixing, batching, and material handling. By using the chart, you're able to compare your manufacturing energy use against the chart to see how it aligns with regional averages. You're able to identify opportunities to reduce energy consumption by improving efficiency or switching to renewable energy sources, and use the data to accurately calculate the energy use component of your EPDs. The NRMCA Eastern Regional Life Cycle Assessment Results Chart is a valuable tool for understanding and improving the environmental performance of concrete products by encouraging stakeholders to use the chart data to optimize their processes and contribute to more sustainable concrete production. The data is specific to the Eastern region and may not apply to other regions. You want to ensure that you're using the most current data, as environmental practices and technologies can change over time. The target most specified is global warming potential, and as you see, it is reported as kilograms per CO2 equivalent. Remember, these numbers are averages of the study. Some concrete mixes had higher or lower global warming potential results. Many specifiers have targeted a percentage of the average as a starting point for global warming potential targets and goals. Environmental product declarations help us make informed decisions by better understanding the environmental impacts of our material choices. It improves sustainability and encourages the use of more sustainable materials in construction practices, and also helps with market differentiation. The products with more favorable EPDs can be more attractive in a market increasingly focused on sustainability. If you would like more opportunities to learn about concrete, cement, and aggregates, please consider utilizing our online e-learning platform. You can learn at your own convenience, have an interactive learning experience, and receive continuing education credits upon successful completion of the courses. If you are interested, please email tricia@pacaweb.org, and you can begin your online educational journey with the Pennsylvania Aggregates and Concrete Association today.